Good afternoon. Nice to see everybody here on the Zoom meeting for our first webinar. Welcome to Data Handling and Machine Learning for Biomedicine. We have about 5 to 6 months in front of us. If you want, join, come in, learn with us. And we're starting today with part 1, which is an introduction to the Python language. Before I go into the details of the course, I'd like to give you a quote from Robert Hooke from Micrographia in 1665, where he says, "And to be had at any time, I found most proper for drawing the representations of those small objects I had occasion to observe." So Hooke is referring here to the microscopic objects, cork cells and protozoa that he saw under the microscope. And he emphasizes the process of drawing what you see because it's a new world of data and you have to learn to see. And likewise, I will argue that in this course, we have to learn to see in the world of digital data. And so this will be our main motto for this course, to use data handling and machine learning in order to better understand data that are otherwise in such a high dimensional quantity that we can't really know what's going on without the use of programming. Right, so I should mention that this is the very beginning of Learn to Discover, a new project funded by UKRI, and that is in our case the Medical Research Council. So our team will be Geraint Thomas as a director, Hannah Heaven as an administrator, Phil Lewis for some technical things, myself for more of the academic content, and we have a couple of tutors with us who I will introduce along the course when they join, for example, the webinars. I think you have all been signed up as far as I see from the list of participants, and you have all successfully logged into the course page, which I'm now sharing. So there's not much more that I want to say about the beginning. We are now in lesson 1, very slowly starting with basic Python. And I hope you will be able to access everything. Before I go any forward, every lesson has a forum with it where you can post any problems. So somebody had a problem on a Mac with a link to a web page, which is due to a known preview problem. Just post it there and see. We'll try to pick them up and hopefully address them as quickly as possible. Right, so we're going in a bi-weekly fashion, and you can download everything there is, and the most important is install Anaconda and use JupyterLab environment. So for the next 6 months, I hope that you will get to start to use this environment, JupyterLab, as your playground. And so before I do anything else, I should just, assuming that you have downloaded the Anaconda distributions as I suggested on the web page, then you should have an application called the Anaconda Navigator. It's this green circle, and if you find it, either you look for it in the command prompt, or you find it, or you have a alias on your desktop, and then of course clicking on it or double clicking it to open it. That will be the start. And if you want, you can just keep that open in the background. It doesn't take any energy, memory, or anything. Once it loads, so it takes a while to load, it's actually a big thing, then hopefully what you get is this here. the Anaconda Navigator opens with a couple of apps that you can start from here. Right, I just adjust the window a little bit. Let's have a look. To open JupyterLab, you navigate to JupyterLab. There are two Jupyters here. There's JupyterLab, Jupyter Notebook here on my screen on the right-hand side. That's the old version. Don't use it. Just use JupyterLab, which is the new thing, which is what all modern applications are using, and particularly if we have occasion later on in part 2 to move to the cloud, then JupyterLab is just the better option. Right, so launch, you can see launch here, that blue rectangle, click on launch, and hopefully it will open a new window. And that window should go in your web browser. So don't be surprised. It's nothing to do with the internet. It's all local, so you can use it even if you have no internet access. And in my case, I don't know if you see that, it gives some warning, may have produced some errors. That's one of the recent versions now. I just updated my operating system. It's nothing that we need to worry about. So I will have new JupyterLab window, bring that up to the front, and oh, there's too many things. Let's just close them all down. This is content that I'm going to do. It will look something like this. So let me just navigate. This is not really very useful. Just go to my desktop. That's much cleaner. And I will briefly show you what we can do here. So it opens. You have this window, which is basically your playground to do everything you need to do within programming. And we'll use it for much more. I will show you just in a second. Quick overview. If you haven't done so yourself, let's start now. So on the left-hand side, there's a couple of tabs you can see. And these tabs allow you to sort of navigate. And what you can see, that folder symbol here on the top left is it helps you toggle between not showing and showing. If it shows, it helps you navigate into your directory. So I'm now in a directory called the desktop, which is my laptop desktop. And you can see the folders which are there. And also the files that I will create will be in that directory. Also, if you download some data later on, it will go into this directory by default, unless you specify something else. Right, what do we need to know about this here? That apart from navigating, then we have the launcher window. By default, it should show something like this. And where it says notebook, you can launch or start a new notebook. So this is, of course, what we need to do. And Python 3 is the one that we're going to go for. If for some reason you have mistakenly Python 2 installed, so it says Python 2 here, download, don't do anything anymore. Delete everything that you have, Anaconda and Navigate and everything, just delete it and download a new version, 2021 JupyterLab, everything with Python 3. So if you see Python 2, don't touch it. If you are a beginner, don't touch it. Just ignore it or delete it. Use Python 3. There are some applications around which use an older version, which is Python 2, but you can always have a workaround, and it's no longer supported. Everything from now on will be Python 3. Within Python 3, it doesn't really matter so much if you have a version that's higher than 3.4 or 3.5 will be fine. And I think Anaconda until today still comes with 3.8, there is a 3.9 somewhere in the background, but we don't need it. This course will be okay with 3.8. And if necessary, we can upgrade later. Right, so that's it. This is your for navigation on the left-hand side. Here's your launcher to open. And if we click on this, we'll have a new notebook open, and that's what we need. This is where we're going to enter code and everything else and do everything that we need to do from now on. The only restriction that we have here, it's not very friendly when it comes to accessibility issues, like screen readers and so on. So if you would like to have a more accessible environment, you have to contact us and we'll try to make it available for you, but that will be another environment. It's the Visual Studio that we use for this, which has better accessibility features. Otherwise, we should be fine here. And what can I tell you about this? So if we open this, you can see there's this gray area here. And this is the cell. This is the place where we enter code. And you can see whenever I click on it, then it has a blue rectangle and it turns white. And that's where we can enter our code. So this is what we want to do. You can have as many cells as you like here. So we'll just execute it, create a new cell at the bottom, and we get some response from the program, which says in this case, SD, just click that away, SDFER, which was a random sequence of characters, is not recognized, of course. This is how we want to work. We want to include any code in here, and we'll do, as a first thing after this, we'll do print hello, something like this, and then we'll work. So what you need to know is that where to put in the code in the cell. See, it also nicely counts every time I execute it. It gives you the count. You can see how often you have executed that. There's code in there and how to execute the code, right? What did I do to execute the code? There are 3 ways to execute a code in JupyterLab, and that's what's the first thing. Here's a little triangle. Can you see my cursor? Okay, if you see that little triangle in the programming editor, it means run or go or execute. I think run is the most widely used. Run selected cells and advance, it says in that little text when you hover over it. And if you click on it, it runs the code. There was nothing in that cell where I had highlighted, so it just advanced to the next cell. If I go back to that first cell, hello L2D, I change the text, execute it, then it will do this, and I can execute by clicking on that little triangle. Another version is to go under run. You can see you have those possibilities, file, edit, view within the web browser. So it's not the one of the web browser at the top maybe, but it's the one within the JupyterLab window. And then it says run selected cells. Where is it? Run selected cells. And if you do this, it will also run the selected cell. So if it was this one here, run selected cell, it will do it. If you go there and you see that run selected cell next to the text, it also has the keyboard shortcut. Keyboard shortcuts, very, very important, because in the long run, when you do many executions, many pieces of code that you want to have executed, you don't always want to use the mouse cursor and move to that thing and click on it. If you learn the keyboard shortcut, that will be your more common way. Typically it is, or at least try it and then pick the one that is best for you. So in my case, it says Shift Enter, and that's what I do when I go to this code. I don't know if you heard that clicking sound in the background. Shift Enter, just the 2 keys on the keyboard on the right-hand side. Shift Enter with 1 hand, 2 fingers, and then you have execute this code and it's done and advance to the next cell. So that's the most frequently used thing. What else? Then maybe you notice here on the top you have a black circle is filled in black at the moment. When I go over it, shows like a little cross. So when I click on it, which I don't do, when I click on it, it will close this window. It's black because black means it has unsaved changes, right? So if I want to save, I can navigate with my cursor here to the left, this kind of disk symbol there. If I click on it, that black circle goes away. It leaves the cross for clicking it, but it means I have saved all unsaved changes and is now fine. Everything will be on your in your file. The local file with the name, as you can see, it's called, you see the name here, untitled.ipynb. That's untitled is the name given by default. If you just open it, it's called untitled. And if you open more, and we can open a second one, and then it's called untitled 1, and the next will be called untitled 2, and so on. You can just click them away. Yes, discard, we don't need that. So it's a default name given to it. Of course, you want to change it. So untitled 1 is highlighted. Here's the one that I don't like, right? So if you right click on that one, you can see the whole menu of things that you can do with it. Like this one I don't like, I want to delete it. Yes, I want to delete this one. And untitled, the one that I'm using currently, I want to rename that and I want to call it hello or something. And you can see as soon as I click on hello here, then it also changes the name. And of course, that's, you want to give it the name that helps you remember what code it contains and why you have been doing this. Right, is there anything else that we need to know? Let me just check. Yes, I want to show you one more thing. So on the left-hand side, with using that folder symbol, click that away. And before we advance, just one thing you can see, well, there are many things there, right? Save on the left-hand side, plus means give me a new cell. So you can create as many cells as you like. Use that, just any new code you want to try something, make a new cell and type your code and test it there. It will only execute that cell, so you can do things in isolation before you put them together and so on. If you don't like a cell, the current cell is highlighted yellow here, highlighted blue here. Use the scissors to cut it away. You can cut all cells away if you like. There's no harm. Nothing will be lost. And you can copy the content of a cell, paste the content of a cell, run. And that square here, the black square, means you stop any code that keeps running for too long. So if you think something goes wrong, like a while loop or something that never seems to stop, this is the way to stop a program that doesn't stop by itself. If you want to know whether or not Jupyter is executing something, go all the way to the right. There's this little white circle here next to Python 3. If it is executing code, if it is running, it will turn black, right? If that circle is black, it means the program is doing something in the background and cannot be used to execute another piece of code. You can do editing of the text, yes, but you can't do more execution of code. Then it's useful if it doesn't turn white again, then it's useful to click a couple of times on this black square here and the program typically will stop. So mostly this is our environment in terms of the coding. Now, JupyterLab has become very, very popular because of a feature that it can be used as a lab book, a notebook, basically an environment where you can sort of have everything that you need in the context of coding in one place. And I'll just show you, I don't show you the details, but I encourage you to learn that. And the cell that I currently have, so this cell here where I've put in some code, is a code. code cell. So it expects Python code and then will execute it. So there will be an interpreter to understand it as Python language. You can change that. For example, you can go to Markdown and then it will no longer recognize it as code. So in this case, this is not what we want because we want this to be recognized as code. But if we make a new one and call it Markdown, we can now put in everything. So just a quick thing. So if you use the hashtag, so you can create a title. And if you execute this cell, you will just see the word title in big capital letters. So you can make a header for a section of text. And then, of course, my text can go all below it. You can write whatever you like, and then you have it there within your notebook. It's more powerful than this. You can then have images included. You can have hyperlinks included. I'll show you an example. So an example of a hyperlink is a Markdown. What is it? Markdown cheat sheet. So here's the hyperlink, Markdown cheat sheet, and then you can click on it, and if things go well, it will open in your browser window. This is now on the internet, of course, a hyperlink to a Markdown guide to tell you how to use Markdown. So very simple things like the hashtag, if you want the heading. This is how you do bold text, italics, ordered lists, everything you can do. It's not meant for publications. So it's not for like fine tuning and proper nice layout of a book or a paper, but it's good enough to make a good, nice text that you can use for any code that you can then share with others. And even you can put it online in GitHub and so on. And the reason why people like Markdown these days is because it's very quickly transferred to HTML, can be put on a website. Click that away. And I think that's enough for introduction. Please learn this environment. It will be your playground, your Jupyter country, so to speak, where you can learn to speak Python. Right, let's start a new one. And let's go to our first introduction. So all the coding, let's just give it a different name. It's not a very nice name. Test. How do I call that? Print something. Let's do the print function. So we'll do three very short tutorials on how to use code. They are consistent with what you have in the PDF for this lesson. And they're also sort of related to what you're supposed to do for your first assignment. But it's more like getting used to the way of working. And especially if you've had a proper programming editor before, you will see this is much more fluent and much leaner in some sense compared to big editor. And if you have been in a MATLAB environment, you will also see that things work differently in Python. And want to discourage to think too much in terms of both languages or 2 or 3 languages at the same time. If you're on this course, I would hope you could concentrate on this one language just by itself, like a proper language, a lingual language. It's also best to just concentrate on it and go to the country where people speak that language rather than try to translate too much from another language. Every culture has its own environment. And the more you get used to this Python way of expressing things, the better you will be doing in applying everything to complicated machine learning code. Right, what can we do with print? So I don't think we need a lot. Print, So one thing that you might notice, I'll make that a little bit bigger. And I click this away so you can concentrate on this text that I have here. Yeah, I might even stop my video. So you need to now concentrate on the screen. And print is an inbuilt function. And you can see that if you do it in your own environment, you can see that whenever you stop, you complete the word. Let me see. If the letter T is missing, it's still black like ordinary typewriter. If it's the complete word print, it turns green. So that's an inbuilt support to do this programming in Python, which helps you to identify names that are already taken. So if you use variables later on, please don't call them print, because print is taken. And it's supposed to go with an argument, sort of what do you want to print, and that goes in parentheses. So you need to learn. Functions in Python typically have arguments in around parentheses. So if you want to print some text, you use quotes. Notice that you press once on single quote, but two appear. So by default in JupyterLab, if you open a quote, it will close the quote as well. The same goes for double quotes, open and close, and the same goes for square brackets, open and close at the same time, but not for other characters. So what we need is single quotes here for text that we want to enter. And I did it before. Hello class. Is that what we want to say? Hello class. And if you execute the code, Shift Enter, then it shows this text that I've put in quotes just underneath the cell that was being executed. So that's a good thing to do. Print has a lot of functionality that we can't discuss in detail. The important thing is that it's an input-output function. So it actually is a function that has this special property of interacting from within the program with the hardware outside the program, in this case, show something on the screen. So there's a couple more of those functions, but they are special functions. One that you have in the materials is input. Input expects text to be input into the program, so that goes the other way around, but it's also an input-output operation. Okay, so what can we do with this? I mentioned that the text that you want printed, in this case, hello class, is called an argument. So that's the content that you want printed. We can print more than one content. So we can print hello class, comma, want to have another argument, another pair of quotes. How are you, or something. And you can see then both things will be printed just one after the other. There's some things that you might notice if you just start experimenting with this code. You can see that these two arguments are separated by a comma here. I have a comma and a space. The space just for visibility, and the comma needs to be there for syntax purposes. So it has to be there to separate one piece of input to another piece of input to that function. You can have as many as you like, as long as they are separated by comma. So you can see that space that I made. There's also a space between class and how. If I make many spaces in my text and I execute the code, the output doesn't change. So it's independent of, it doesn't really matter how many spaces you put in between those two arguments. If, however, I put the space within the quotes, then those spaces will be properly reflected in the output. Right, so it means whatever is within the quotes will then be taken as you put it in. And if you put some funny characters in there, then these will also appear in the output, right? In this case, I just put in a couple of parentheses. They will just come as they are. So within text, everything is interpreted as a character. A couple of more things that we can do. Let's do another round of print, and within quotes, hi there. So we have two input arguments, hi and there, and they're separated by a space. Now we can, of course, also separate them, as you saw it, by characters, but there's also a special way of defining how you want arguments to be separated. To define how you want things separated, you use the keyword argument. Right? The keyword argument is sep. You need to know that. You need to learn that. It's sep, and it's equal to what is it equal? Well, then you can say what you would like to have in between. So if you want a couple of zeros in between, then you can do that. You can say the separator is a couple of zeros. If you think that doesn't look very nice, maybe you can put in space and so on, right? And anything that you put in here, if you put in a lot of zeros, it will just appear as a separator. So that's one way of specifying what you want to have between arguments. It could be a comma. If you like to see a comma between arguments, just put it in here. And then we're done, or period. No, we want to have a comma. And now it's separated by a comma. And if you think there shouldn't be a space on the left-hand side, then take it out. And now hi, comma there, or hi, whatever you want to do with it, right? So you understand the way the separator is used. If I just copy that code, and one thing that is a little bit different from what I've said so far, namely all characters are just printed as they are. Well, not all characters. It's a bit of a special character, and that is the backslash. And something that you have to learn. And you can use that to sort of escape a character from just being treated as a character and meaning something else. So special meaning is, for example, reserved for \n. And we can, if you see that, we can just execute the code. If you know it, maybe you have seen it before. It's not only Python, it's also in other contexts. \n typically interpreted as new line. So if you want things separated by new line, say you have several results that you want to have printed, and you want them not in one line, but separated, each result in a new line. This is how you could do it. Use \n, and that sort of meaning as a new line after every argument. You can also specify the last separation within a set of arguments. I don't go into this, but I will just show you how you can find out. What else you can do is you use help. It's also turned green. So it's another inbuilt Python function. And for help, you can put in any function that you have in Python, and any inbuilt function like print. And you can say, give me a help for print. So, and this will then tell you what you can do. The way to use print is to use round parentheses, and then there's something in between. And there are values. This is what I call those text strings within quote. And the next thing that is explained is that separator that I just mentioned. And there are more arguments, but you will have to start to read up on this. So this is the help that you can get, and it tells a couple of things. In the beginning, the help is a little bit hard to interpret. If you're a beginner in programming, it will not be easy to comprehend, but the more you use it, the more you will get used to it. And of course, the more you use the function. for example, the print function, the more you can try to make sense of what is being said here. So let's finish this with two small comments. Quotes, within quotes, so I put the characters. Another escape character to have a special meaning is \u, capital U, and that's for Unicode. So Unicode meaning you have to know the Unicode, which means you have to sort of know how a specific character is encoded in Unicode. And you can do that to get sort of special characters or special symbols or even emojis in this case. What is that? F4TD. Let's see if I do the right thing. If you use the Unicode 001F40D, I'll zoom into it a little bit, and you have to do it on your own screen. That's the Python. That's the snake or serpent. And of course, you can do any smiley or whatever you like to do with it. So yes, there are many things that you can use in Python. And of course, you can find all online. I would recommend, if you start to learn things, use the Python online documentation. It's python.org, and everything is with there. There's loads of tutorials from the very beginning to advanced settings. Just start using them, go there. And the widely used one that I see that is very helpful for beginners into the Python language is the glossary. So if you search for the Python glossary in the original Python documentation, python.org, you will find that extremely helpful, because many of those technical terms that maybe you are not so used to, there you will find a good explanation that helps you to make sense of it. So also when you use the help, either online documentation or help like we did it here from within the code, there are of course many technical terms, and this is written by programmers for programmers, so it's supposed that you know those things. If you learn those things, the glossary is a good starting point. Right. That's the time. Good. That's enough for this. Let's make a new notebook and come to the next topic. Next topic is just a little bit about operations. So operations means what can you do in Python. And I think if you have seen another programming language before, it will be fairly trivial, apart from a small changes compared to other languages. If not, I think even so, just using it as a typewriter. Well, let's start with entering 5, just the number 5, and executing the code. You can see, you just see what you have entered. That's not all. Typically, we want to avoid to work with specific numbers, because in data science, today is this number, tomorrow is that number. So we try to assign it to a variable like a = 5. So then we have created a variable called a. And what does it contain? Well, the easiest way to check is, of course, to say print a. We have learned print, so we can print it, and we can see the content is, of course, 5. Another way that we can do, we can just put a here just by itself at the end of the code. And if we execute the code, you can see that it will also show the content of a. So it's very similar to print a. And depending how things are set up, this can be similar or slightly differently formatted. But here you can see this is a feature of JupyterLab notebooks. the last thing that is not assigned is just being shown as an output. So if we had the number 5 here, it shows the number 5, and if we put a here, it shows the content of the variable called a. So that's something just to remember. And then we go further, and then of course you can do things like, I don't know, add 1 to a, and 5 plus 1 is 6. Or you can multiply with the star times 3, 8 times 3 is 15, and so on. So I think that's fairly straightforward, and you divide by using the forward slash. Let's do an example. Divide by 2, and divided by 2, it's 2.5. So that all works in a straightforward way. One thing that's a bit different maybe, if you use a itself to calculate a new value for a. So you want to reassign a value of a. For example, you want to increase it by 1. So you say take a, add 1, and assign it to a. So replace the former value with the value that is of 1 larger. So if we do that and type a here, we can see what happened. Now a is 6 because we have added 1, obviously. And what I want to show is a nice shortcut that is not there in all languages, but in some, and specifically in Python, you can shortcut this as a plus equal 1. So the meaning of a plus equal 1 is take the contents of a and add 1 to it. So what would you predict will be now? A is 6, add 1 to it. See what happens. Well, we have to see it also. If I put it a here, now it's 7. And if we put a here and delete this one, and if we keep doing this, it will just keep adding 1. The more we execute it, the higher it will be. And interestingly, the same thing also works with multiplication. So you take a and you multiply it with whatever is on the right-hand side. So if a is 11 multiplied by 1, that will just remain 11 forever. Okay, so multiplied with, say, 3, then 11 times 3 is 33, and so on. And it also works dividing by 11, and then you get back 11. So this is a way, no, I have to do this, divide by 11, and then we get 1. 11 divided by 11 is 1, right? So it's a shortcut, a nice notation that makes code readable as soon as you understand this combination of operators. Right. So these are basic operations. I've mentioned things like multiplication and division. I should also mention that there are things like 10. If you divide 10 by 2, the output will be 5, but you can see it's 5.0. If for some reason, so that's the division, but it gives you back a floating point with a decimal point, 5.0. If you like to have it as an integer, sort of 5 as an integer without that decimal point, you can also get this, but you need to do a double slash. That's the integer part of the result of the division. And so it will be the same also if you have 11 divided by 2, it will still be 5 because it's the integer part of it. The result would be 5.5, but you only see the integer part. And finally, the remainder. Percentage gives you the remainder, which is 1. So 5 times 2 is 10. So the remainder is 1. And that's the percentage sign. I think that's about the important things here. One thing that is different from, for example, MATLAB, if you know the power of in MATLAB. So if we have 2 to the power of something, in Python will be to the power of expressed as star star, so the double star. 2 to the power of 3 is 2 double star 3. And maybe if you remember in MATLAB, that's the head, but the head will also do something in Python, but the outcome is very, very different. And it's also not an easy thing. It's the exclusive or XOR, and you have to know binary notation to understand this thing. So what you should learn is to not use it until you really need it as a logical expression. And to the power of is this one here with double star, and it also works for square roots and so on if you put in 1/2. Right. So that's it, what we need for operations. And I think for a final topic, we move now to logicals and conditional statements. So let me just get a new notebook here. It's now Untitled 1. Just leave it, that's fine. Right, let's have a quick look at logical and conditional statements. So we have 2 logicals. We have false and true. And you can see if I have 2 items separated by comma and I just type them in and press Shift Enter, they will come as a pair in parentheses. We'll see later what that means, separated by comma as well, but means you can have multiple items in a line. And false or true, they're both highlighted green, they're internal. If we want to find out of what type they are, what do these things mean? So we use a function called type. And if we apply that to false, it tells us bool. Bool meaning Boolean. So it's a logical thing that we use to express false or true if we check a certain condition. Internally, these are represented as 0 for false and 1 for true, which is good to know. And the way to use them, use logical expressions in Python, is very straightforward. If I say 1 = 1, this is not an assignment like we had before, a = 2. We had an assignment of the number 2 to a variable called 2. If we use the equal or double equal, the logical equal, then this is a question. And the question is 1 on the left-hand side equal to 1 on the right-hand side? Is it? We check by Shift Enter executing this code, and that seems to be true. So, and of course, equally we say, is 1 equal to 2? Then the answer is false because it's not, obviously. And we can do that. Typically we don't work with explicit numbers, but we use variables. So let's start this practice right away. Let's define 2 variables, a and b, and I assign 1 to a and 2 to b. Notice that I can do that in a single line. It can be more than 2, it can be 3, 4, 5, or 6 variables if you like. So if I do that, let's first check a and b. So we have assigned 1 to a and 2 to b, and here they are. A and b are 1 and 2. So what we would like to do now is would ask, are they the same? Is a equal to b? It's the more generic way compared to before, but of course the answer is no, because they are not. Now the question is, can I negate this? Can I say, is a different from b? Yes, I can do that. And the way to do that in Python is to use the exclamation mark. We combined with the equal sign. Is a not equal to b, or is a different from b? Well, yes, it's different, so that is true. So these are some of these logical expressions, and you might not be surprised to see that we can ask, is a larger than b? is A smaller than B, and so on. Is A larger equal to B? Also works, is A smaller equal than B, and so on. All these things can be asked. And you can also combine statements. A smaller than B and A larger than B, what would you think? Can they be at the same time? Can A be at the same time smaller and larger than B? No, it cannot be at the same time smaller and larger. So this expression overall evaluated is false. If I copy and paste the code, just copy, paste the code and say, is A either smaller or larger? Well, yes, it's either smaller or larger. Naturally, it's one of the two things because they're not equal. So it will be either smaller or larger. And so on. So up for you to practice. Let's quickly see that, of course, when we do this in a bigger piece of code of checking data for certain properties, this is where we're going to apply it, then of course we will not just put in the expression, the question, and see that on the screen, but we want to work with the outcome. So the answer, so we assign it to a variable. Like before, we can assign this expression to a variable, and we can then see what is the content of this variable. And the content of this variable is just the logical value, which is either false or true, because on the right-hand side is a logical expression. Yeah, so you can see that these things are straightforward once you get used to them, but it needs practicing, and you have plenty of material in the text that we have provided for this lesson. So let's finish today's introduction to the Python language with a look at conditional statements. So I can as well use that in Markdown. Making a Markdown cell, there's a couple of things that you need to do when you want to work with conditional statements. First of all, what we have done just now is to test a logical expression. So that's something that we need to do when working with it. So we'll test the logical expression, and we know the answer will be true or false. And then we take a decision. Take a decision based on the outcome of the test of this logical expression. We have to take a decision because I say, depending on what is the outcome, do one thing or another. And then what we want to do is provide directives, provide or say what should be done, right? That's the third thing then. So that's how we do it. We test the logical expression. We take a decision based on this expression, and then we follow up with some directives on what should happen next. So let's give an example. Let's define two variables, A and B. I don't know, 1 and 2, just some arbitrary values. And then we want to have a logical expression. Say we are interested in whether A is larger than B or not. So the way to express this in Python is the if condition, if statement, if A is larger than B. And now we want to say, then do the following. So the syntactical way to do, then do the following, is to put a colon, make a new line, and indent. Very important, indentation in Python. It's unforgiving. You have to indent, and you have to consistently indent. Say print A. So if it's bigger than B, you should print A. Let's execute this code. I outdent and I execute the code, and I see nothing is happening. Why not? Well, A is not larger than B, right? It was supposed to happen if A is larger than B. So if A was 3, it would print it because then the condition is fulfilled. If it's not, what's that? Made an error here, correct the error. If it's not, if it's smaller than just nothing will happen. So we can continue, we can address this by saying, well, in this case, nothing happens, but I can put another condition and then find out what happens, and that's the elif. Else if, what is another condition? Well, maybe A is smaller than B. So I can also do that. Colon indentation. What do you do if the other case is true? Then print, don't know, print B or something, right? So in this case, we will always have something printed because it's smaller or larger. Well, not all cases. The final case, the one that's missing, and that's the last thing that we need to know in this if clause, if first condition, elif, as many other conditions as you would like to do. Finally, everything else, so to speak, can also be implemented, and the way to implement everything else is else. So everything else followed by a colon, just all the other cases. And we know there's one, of course, and then we can say print, do it print, and free the end. So what will we see? We will see 2 in this case printed. I need to make that a little bit smaller so you can see the outcome. So this is our whole code. And we see a 2 because A is smaller than B. If A was larger than B, we'll see a 3. We'll see A printed because now A is larger than B, fulfilled. What if they are both the same? So I now make A and B the same. A is 3 and B is 3. And then, of course, that's one of the remaining cases, which is the end. Brings us to the end of today. Thank you very much for watching. There's a deadline for the assignment submission of this lesson, which is Sunday next week, so in 10 days from now. Once the deadline is passed, there will be a model solution on the web page, which you can check, and we then proceed in 2 weeks with another webinar on lesson 2, the contents of which is arrays. So let me just back. Contents of which is arrays, which means arrays is our way of putting data into Python, of course. Arrays are the containers for data. So this is a fundamental topic. We will learn that there are different types of arrays. Different types is a bit different from other languages. Different types of arrays which we can then use for our benefit when we do proper data science. So if you want, thank you very much for watching today. See you in 2 weeks, or have a look at the recording of the webinar on our webpage.